Hello everyone, I am M. Uma Priya, working as Assistant Professor, Department of Computer Science and Engineering in Hindustan College of Engineering and Technology. In this presentation, we are going to see about nonlinear data structure, trees. So as we all know, data is nothing but organizing the data in an order. So the data structure is divided into two categories. One is linear data structure and another one is non-linear data structure. In linear data structure, the data is organized in sequential order, and in non-linear data structure, the data is organized in random order. So this presentation will tell you the basics of non-linear data structure, tree. So what is a tree? A tree is nothing but collection of nodes in which the data is organized in hierarchical structure. Every element in tree structure is called as node. And the node stores the actual data and link to the next node in the hierarchical structure. Now, example for a tree structure. So this is what the tree structure I have here. See, here in this example, there are nodes from A to K. So the circle represents the nodes and the line connecting the two nodes represents the link between the two nodes. I call this link as edge. So here in this example, I have totally 11 nodes and 10 edges. See, from A to K, I have 11 nodes and 10 edges. So in general, if I take any tree, a tree will have n nodes and n minus 1 edges. Now we will see some terminologies. So the first terminology is root. What is a root? So the first node in the tree is called as a root node. Every tree must have a root node. So there is no tree with no root node. Okay, so here in this example, A is the root node and the second is edge. So edge is nothing but the connecting link between the two nodes. So say on the right side I have an example. So there I have some set of nodes from A to K. See, I have a link connecting, a line connecting node A and node C. So that particular line is called as an edge. And also from B to E there is a connection. So that connecting link is called as edge. And the next terminology is parent. So the node which is predecessor of any node is called as parent. See, on the right side I have an example. This A is the predecessor for B and C. Similarly, B is the predecessor of D, E and F. So this B is called as a parent node. Similarly, C is the predecessor for G and H. So C is the parent node. The next terminology is child. So the node which is descendant of any node is called as child node. Here on the right side, in this example, node B and C are the descendant of A. So this node B and C are children of A. Similarly, I and J are descendant of node E. So I and J are children of E. The next terminology is leaf. So the node which does not have child is called as a leaf node. So on the right side I have an example. Node D does not have any children for it. There is no left child and there is no right child. So D is the leaf node. Similarly, I, J, F, K, H, these nodes does not have child. So these nodes are called as leaf nodes. And the next terminology is degree. So degree is nothing but the total number of children the node has. So take this example. This node G has only one child. So degree of G is 1. Similarly, take C node. This node C has 2 children, G and H. So the degree of C is 2. And what about the degree of k, it does not have any child, so the degree of k is 0. Okay. Terminology is level. So level as such in a tree we will name from root node. Always root node will be at level 0, and after the root node the next nodes will be at level 1 and next nodes will be at level 2, and it will go on until the length of the tree. And the next terminology is height. So the total number of edges from leaf node to that particular node is called as height of that particular node. So in this example, you can see node C has height 2. How? From leaf node. So take the leaf node K. So K is the leaf node. From K to G, I have one edge, and from G to C, I have the next edge. So totally I have two edges. So which indicates the height of that particular node C. So the height of C is 2. Similarly, when I go to root node A, how I can reach A from leaf? So from K to G there is a path, from G to C there is a path, and from C to A also there is a path. So from K to G I have one edge, from G to C I have second edge, and from C to A I have third edge. So the height of node A is 3. So if I take a tree, if I need to calculate the height of the tree, the height of root node will tell me the height of that tree. And the next, depth. The total number of edges from root node to that particular node is called as depth of that node. Say for example, if I take node C from root node, here in this tree the root node is A. So from A I have only one edge, so depth of C is 1. And if I take K from root node, I have to reach K. So for that I have to move to C, that is one edge. From C I have to move to G, that is the second edge. From G I have to move to K, that is the third edge. So the depth of K is 3. Always the root node is at depth 0. Okay. And terminology is path. So the sequence of nodes and edges from one node to another node is called as path. Say for example, if I want to reach J from A, what is the path there? What is the sequence of nodes and edges there? From A I have to move to B, from B I have to move to E, and from E I have to move to J. So this is the path. A, B, E, J is the path for moving from A to J. Similarly, if I want to reach K from C, means from C I have to move to G, from G I have to move to K. Now what is the length of the path? The total number of nodes in that path gives me the length of the path. So from A to J there are total number of nodes is 4. So the length of the path A to J is 4. So this presentation gives you the basics about trees. Thank you.